Today, we are going to learn about mass and weight. These two terms are often used as if they mean the same thing, but in science, they are quite different. By the end of this session, you will understand what each means, how they are related, and how they differ. Weight is the gravitational force that Earth exerts on an object. Everything is attracted towards the center of the Earth because of gravity. The more massive an object is, the stronger the force pulling it down. Force of attraction is weight. SI unit of weight is Newton. Weight is not the same as mass. The gravitational force exerted on an object is equal to mass multiplied by acceleration due to gravity. So we can say that the formula for weight is mass multiplied by acceleration due to gravity. On Earth, the acceleration due to gravity is about 9.8 meters per second squared. For example, if a person's mass is 50 kg, the weight would be 50 kg multiplied by 9.8 meters per second squared, which is equal to 490 kg meters per second squared. And kg meters per second squared is nothing but Newton. So the weight of this person is 490 Newton. Let's take another example. In this case, the mass is 100 kilograms. So weight would be 100 kg multiplied by 9.8 meters per second squared. That would give us 980 kg meter per second squared. So the weight of this person is 980 Newton. Notice that when mass doubles, weight also doubles. Mass stays the same, but weight depends on gravity. On another planet where gravity is different, the weight would be different, but the mass remains the same. Gravity is not just Earth pulling on you, it's a universal force. The gravitational pull between any two objects depend on the masses of the objects and the distance between them. If the distance between objects increases, the gravitational force decreases. Because Earth and Moon are massive, they attract each other. But you and your pencil don't notice the attraction. Why? Because it's too small. When the distance between two bodies increases, the gravitational force decreases. This is why astronauts in the International Space Station experience microgravity. They are farther from the Earth's surface, so the gravitational pull is weaker. If you could move, let's say, twice as far away from Earth, what would happen to your weight? Your weight would decrease. Your mass never changes. It is the amount of matter in you. But your weight changes depending on the planet. On Earth, let's say if the mass is 60 kilogram, the weight would be 588 Newton. I'm multiplying the mass by the acceleration due to gravity on Earth. Whereas on Moon, the acceleration due to gravity is 1.6 meters per second squared. It is less than that on Earth. So the weight would be 60 multiplied by 1.6, which is 96 Newton. So you are much lighter on the Moon because gravity is weaker, but your mass is still the same. Now let's see what happens on another planet, Jupiter. Here the acceleration due to gravity is about 24.8 meters per second squared, which is more than twice that of Earth. So if a person has a mass of 100 kilogram, on Jupiter, the weight of that person would be 2480 Newton, 2480 Newton. Now, assume that your weight on Earth is 600 Newton. Can you estimate your weight on Jupiter? Yes, you can estimate. It would be roughly 2.5 times more, so about 1500 Newton. To measure mass, we use a beam balance. A beam balance compares an unknown mass with a known mass. So these apples have mass of 1 kilogram. Mass measurement does not depend on gravity. It's the same everywhere in the universe. To measure weight, we often use a spring balance. Here is how it works. The gravitational force pulls on the object. The spring stretches in proportion to the force. More force means more extension. Less force means less extension. This means a spring balance directly measures weight, not mass. If you hung the same object on a spring balance on Earth and on Moon, would the reading be same? No. It would be much less on the Moon because gravity is weaker on the Moon. Now let's compare mass and weight. Mass is the amount of matter present in an object. Weight, it is the gravitational force of the Earth acting on that object. SI unit is kilograms. SI unit is Newton. Measuring instrument is beam balance. And for weight, the measuring instrument is spring balance. Does it vary from place to place? Mass does not vary from place to place, whereas weight can vary if the acceleration due to gravity varies. Can mass be zero? No, mass cannot be zero. However, weight can be zero where there is no gravitational force. Mass is a scalar quantity and weight is a vector quantity. So what did we learn in this session? We learned that mass is the amount of matter in an object and is measured using a beam balance in kilograms. Weight is the gravitational force on an object and it is measured using a spring balance in newtons. Weight is calculated as weight equal to mass multiplied by acceleration due to gravity. An object's weight changes with gravity. On Moon, the weight will be different. On Jupiter, the weight will be different. But mass remains constant. Gravitational force between two objects depend on their masses and the distance between them.